Today we will demonstrate how can we count random numbers like 70 to 79 and 80 to 85. You can vary ranges as well with the help of two 7-segment displays and only one 7-segment drive. So hello everyone, this is Akash Patel and you are guys watching Learn with IITM 369 Lover. So without further delay, let's get started. So this is a circuit diagram which is provided by professor, and this is come with the logic which is a count 0 to 15 in 177 display, like 0 to 5 first count 0 to 9 and then it will count 0 to 5. It means overall it will count 0 to 15 in 177 display. So I have made this circuit along with the pin configuration which is provided by professor, and also I have used this circuit in the week 8 experiment. Overall it means you have to make first week 8 experiment and then slightly modification will become a lab experiment also. I mean you have to do slight variation in this circuit and just it will be able to count random numbers also. So yeah, I have made this circuit. As you can see that this is the circuit which I have made by using this circuit diagram. So first I will demonstrate counting 0 to 15 in only one 7-segment display. So that pin configuration circuit diagram which is I have made, it's count 0 to 15 in one 7-segment display. Okay, so I have just take the output from the drivers and connected respectively to the 7-segment displays in LSB sides. So let's provide the VCC to this circuit. Yeah, you can see that it's on. So default it is showing 5. Okay, so let's vary the input values and look at what will happen. So I will connect inputs voltage of the comparator to the 0 0 0. It means overall 0, so it should be show 0 in the 7-segment display. So yeah, you can see that it's showing 0 on the 7-segment display. Let's vary the inputs. So I have provided a 0 0 1. It means 1. It will show 1. Yeah, and now we have vary 0 0 1 0. It will become 2. So yeah, you can see. And now we have connected 0 0 1 1. It will become 3. So yeah, our circuit working perfectly. So let's automate this process with the help of a counter, which we have used in the week 5 experiment for the counting 0 to 15 with the help of LEDs and counter. So I have connected LSB to LSB and MSB to MSB to the counter output. And we have to provide clock pulse counter for the counting the values. So this time I don't have any clock pulse generator, but so I will use Arduino. You can use clock pulse generator like 555 IC or 74LS04 IC to generate a clock pulse. As you can see that it's started counting from 0 to 9 first and then 1 to 5. It means overall count 0 to 15 in one 7-segment display. So let me show the code which I have provided to Arduino for working as a clock pulse generator. As you can see that, so I have constant the pin 8 and in setup part pin 8 as I will use as a output, and just define the high. It means it will provide 5 volt along with the 1 seconds, and then it will provide 0 voltage along with the 1 second also. It will work as a clock pulse. So now the main problem comes in. When you go to the campus for the lab visit, lab work, professor will provide a range of the numbers you have to display in the 7-segment display using one 7-segment driver and along with the BJT logic. You have to make a driver with the help of BJT also for the driving the MSB part 7-segment display. So this is the problem which will be provided by professor. So now let's move on that part. How can we count random numbers range like 7 to 79, then 90 to 95. So this is our goal. So let's get started. So as you know that this BJT works as a switch, isn't it? So this is a metal pin, metal cap BJT, which is NPN BJT also. This pin shows that it's emitter, and middle one represented the base and the third pins represent its collector. So emitter will be grounded always, collector will be connected with the VCC, and base will be connected with the carry out of the adder. So the logic behind it, you have to control only MSB part. I mean LSB part will be handled by using the driver also. So you don't have panic with the LSB part. You have to control only MSB part. So first decide what will be the LEDs of the 7-segment display of the MSB part have to on when the carry out is 0. I mean when the LSB part counts from 0 to 9, then what LEDs of this 7-segment display of the MSB part have to on. In my case, I have to on 7. I mean I have to show 7. So it means when the LSB part counts 0 to 9, then MSB part should be show 7. The LEDs of say A, B, C to show the 7 in MSB part, isn't it? And then when LSB part started 0 to 5, I mean count 0 to 5, then carry out become 1. So in this case, you have to decide what LEDs have to on for showing the values of the MSB part. In my case, I have choose 9. So when the LSB part count 1 to 5, then MSB part should be shown 9, isn't it? So I have to on FG along with the ABC for the showing the 9 in MSB part, isn't it? So yeah, this is the logic behind it. So first I have connected pin number 4C to the ground, and then pin number 6 let's connect with the ground also, and then pin number 7 also let's connect with the ground along with 220 ohm resistors. So yeah, this is our logic. When it will count 0 to 9, then it will show 7 in the MSB part. Now we have to control. When carry out will be 1, then we have to on this F and G part of MSB also, isn't it? So I have to sorted F and G pins and just connected with the BJT along with logic. Due to our BJT work as a switch, so when carry out will be 1, carry out pins connected with the base of the BJT will be on when the carry out will be 1, and BJT will be off when the carry out will be 0. So I have connected, pin 9 and pin 10. Let's connect with the collector along with the 1K resistors also, isn't it? And for operating this MSB LED, I have to provide VCC to the pin 3. So let's provide the clock pulse and the input for the variation. Oh, sorry, I have connected dot pin. So yeah, let's remove here and just connected with the pin 4 of the MSB 7-segment display. So yeah, you can see that it's started. So let's see it will count or not. Yeah, you can see it's started 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 90. Yeah, and 91, 92, 93, 94 and 95, and then again 70, 71. Yeah, it's repeated same thing. So our experiment has been completed. This is the problem which we will provide professor in while doing in campus lab. So yeah, this is the logic behind it. I hope you have understand what is the logic behind it and how you will be proceed with this. So I'm going to demonstrate NOT gate, how you can make NOT gate. I know many of you required NOT gate also while doing this experiment. There are some numbers in MSB part you have to show, like if you want to show MSB part 1 and then 2, then you have to use inverter also for the inverting the value when you will switch 1 to 2. So in that case you have to use inverter. So how you can make inverter by using the BJT. So I have just demonstrated that thing also. You can use as your requirement, and when we connected base to the VCC, then it will off, and when we will disconnected base to the VCC, then it will on. I mean base VCC 5 volt, then the LED will be off, and when base voltage will be 0, then LED will be on. It's work as a inverter. So yeah, you can use this circuit for the inverting part also. So yeah, this is the demonstration of an inverter by using the BJT. You can use as you per your requirement. So this is the circuit diagram of that thing. So our experiment has been completed. Best of luck, do well, and do subscribe also. Yeah.